One of the words that we used when we were defining a function was the word domain. And the domain was related to the set A, or the input set of variables that we were using, or the input set of numbers. And so we'll discuss how to find a domain of a function. Well, if the domain is given by a graph, and the graph is only discrete points, the domain of the function will only be the x-coordinates of those discrete points. For example, this has an x-coordinate of -2, x-coordinate of 0, x-coordinate of 1, an x-coordinate of 3, and an x-coordinate of 5. So the domain for this discrete function that's represented by a series of points plotted on a coordinate plane are just the x-coordinates for those points on the coordinate plane. The domain for a function, to check what the domain is for a function that's written as the equation of a function, we have to ask ourselves, what are the acceptable values that I can put in for x for that function and still have a valid equation? For the first half of our class, we are going to be dealing solely with the real number system, so we won't be dealing with complex numbers. So my question is, what are the valid real numbers that I can put in for x and still have a valid equation? Well, you can put any real number in for x and have a valid equation. And the way we write all real numbers in interval notation, it would be the numbers from -infinity to infinity. Ask ourselves the same question. What numbers can I put in for x and square them and still get a valid equation? Well, I can put negative numbers in for x and square them. I can put 0 in for x and square it and still be valid, and positive numbers. So again, I can put any real number I want to into the x squared function or the squaring function and get a valid equation. So its domain is, again, -infinity to infinity. By extension, I can do anything I want to an x cubed function, and I will still end up with a valid equation. As a generalization, every polynomial function has a domain of all real numbers. So if it's a polynomial function, its domain is going to be all real numbers. Let's go over to the next one. The function, the square root function. What numbers make this square root a valid operation? Well, the only numbers that I can take the square root of in the real number system are numbers that are non-negative. So to figure out what the domain is, I always write down what that relationship is. Well, x has to be non-negative, so in this case, x has to be non-negative, which is greater than or equal to 0. An extension to this is if I wanted to know the domain of the function, the square root of x plus 2, I set the portion that's underneath the radical and set it greater than or equal to 0 and then solve. So I know that x plus 2 has to be greater than or equal to 0. Subtract 2 from both sides, I know that x has to be greater than or equal to -2. And the way I would write this in interval notation was with the square bracket -2 going to infinity. And for the first one with the interval notation, it goes from 0 to infinity. What's different between the square root and the cube root function is that the cube root function, I can put negative values in here. The cube root of -1 is -1. The cube root of -8 is -2. I can put 0 in there. Cube root of 0 is 0. Positive numbers, cube root of 8 is 2. So cube root and basically any odd-rooted function, its domain is all real numbers. For the next one, the reciprocal function, I need to ask myself, what numbers can I not put in for x? Well, if I put a 0 in for x, this function is undefined, so my domain is everything except for 0. And the way I think about finding the domain of related functions is I set the denominator not equal to 0 and solve that equation. So right now the domain is x is not equal to 0. The way we would write that in interval notation is from -infinity to 0, non-inclusive. unioned with 0 to positive infinity. The related function 1 over x plus 5, if I want to know what the domain of that function is, I set x plus 5 not equal to 0 and solve that inequality. Subtract 5 from both sides, and I know that x has to be not equal to negative 5. So, interval notation, it would be negative infinity to negative 5, unioned with negative 5 to infinity. My last example is the absolute value of x function. What numbers can I put in the absolute value function? Well, I can put negatives in because they return positives. I can put 0 in there, and I can put positive numbers in there. So the domain of the absolute value function is negative infinity to infinity. So the two functions we have to watch out for so far are the reciprocal function and the square root function. Those, I showed you tests on how to find your test to find the domain for those two functions. All the other functions that we're going to start with have a domain of all real numbers.